Vast lava fields within the upper half of North America. There are a surprisingly high number of vast geologically recent lava fields that each span tens of thousands of square kilometers. These include the Snake River Plain, including the craters of the Moon volcano which owe their existence to the Yellowstone hotspot, the high lava plains in central Oregon which contains 3 active volcanoes, and most famously the Columbia River flood basalts which repeated flooded large swaths of the Pacific Northwest with lava between 17.5 and 6 million years ago. Yet, there is also one large Canadian lava field, such geologically young vast lava field in Canada, which if you live in British Columbia you have probably already seen but likely don't know its name. Located between the Caribou Mountains to the east and the Coast Mountains to the west, is a 44,000 square kilometer or approximately 17,000 square mile area covered by the same distinctive composition of young lava flows. These lava flows span large swaths of the Chilcotin and Fraser rivers, including just south of where the recent landslide that temporarily blocked a river occurred. Known as the Chilcotin Basalts, this now Chilcotin Basalts presumably extinct province forms hundreds of large plateaus as the lavas they erupted were quite fluid and tended not to build in large volumes in a single location. Altogether, an area equivalent in size to about 70% the size of the state of West Virginia is covered by what some scientists estimate to be 3,300 cubic kilometers of basalt lava. In other words, the entire shaded area has an average of 75 meters or 246 feet thick of lava from this volcanic province. So, why and when did the Chilcotin basalts form? While the vast majority of lava flows that comprise the Chilcotin basalts formed between 10 and 1 million years ago, a select group formed as far back as 31.6 million years ago, and as recently as 170,000 years ago. Typical eruptions looked almost identical to what is witnessed in Idaho's Snake River Plain. Typical eruption multi-month to multi-year-long eruptions would form from cinder cones or fissure vents, sometimes involving moderately explosive eruptions, but generally the explosive component was quite low. Eruptions would send out lava flows that advanced at speeds upwards of 10 kilometers or 6 miles per hour, quickly covering everything within a several kilometer radius. Then, lava flows would combine into a singular channel that advances downslope, eventually filling low points in topography such as valleys with hundreds of feet thick of basaltic lava. Each eruption would generally have the shape of an ovaloid near vent which would become a narrow squiggly line